This program is about Rucker Offshore's tensioner systems. In it, we take a look at riser tensioners and guideline tensioners. You've been given a workbook that looks like this. Whenever we want you to use it, you will see this sign. Now turn to page 1 in your workbook. See the list of objectives? If you pay attention, that's what you will get from this program. What the tensioners are used for, how they operate, identification of components, basic operating procedures, and servicing and troubleshooting. At certain intervals, we will ask you to stop the playback unit and take a quiz. These are self-checks designed to help you know if you are understanding the information. The last quiz in the program will be graded, so if at any time you're unsure about a certain portion, feel free to rewind the cassette and review the information again. Now, if you're ready, let's learn about our tensioner systems. Rucker tensioners are designed to provide a means of controlling tension in a wire line when the effective free length of a cable must be varied to accommodate uncontrollable movement in one or both ends of the cable. This sort of movement occurs between a floating drilling rig, heaving in sea waves, and a marine riser pipe attached to a BOP stack anchored to the ocean floor. Our tensioners are built in 4 sizes, rated at 80,000, 60,000, 16,000, and 14,000 pound tension capacities. The 2 larger sizes are intended for use in tensioning riser pipe, and the smaller sizes are for maintaining tension in subsea BOP stack guidelines. Although these models vary in physical size and detail arrangements, they all operate on a common principle, namely the use of a compression cylinder as a pneumatic spring backed by a large volume air pressure vessel. All Rucker tensioners have a pneumatic hydraulic cylinder with wire rope sheaves on both the blind or fixed end and the rod or movable ends, with 2 wraps of wire rope around the 2 sheave assemblies. One end of the wire rope is connected to the load. In the riser tensioners, the other end of the cable is anchored to the tensioner. In the guideline tensioners, the other end of the cable is attached to a winch. All Rucker tensioners have a high-pressure air vessel connected directly or indirectly to the cylinder blind end. Since the volume of the air pressure vessel, or APV, is large with respect to the volume of the cylinder, it allows the cylinder to pay line in and out as the rig heaves up or down. In our guideline tensioners, the air pressure is allowed to work directly against the cylinder piston. In the riser tensioners, an air oil accumulator between the APV and the cylinder pushes air pressurized hydraulic oil directly against the cylinder piston. Instead of air in direct contact with the piston seals and bearings, oil is used to provide added lubrication, thus increasing cylinder service life. Now we're going to take a look at each type separately. Because both have many similar components, we will mention some briefly under one heading, then go into more detail under the other. A riser pipe is used to return the drilling fluid to the drilling vessel. It also guides the drill pipe. In water depths greater than 200 to 300 feet, it must be partially or completely supported by a tension device, or it will fail. Our riser tensioners are available in 2 sizes: 60,000 pounds of tension with 40 feet of compensation, and 80,000 pounds of tension with 50 feet of compensation. Riser tensioners are installed in systems utilizing 2, 3, or 4 pairs of tensioners. The tensioners are combined in pairs to provide these system capacities: 240,000 pounds, 320,000, 360,000, 480,000, and 640,000 pounds. The tensioners are designed to provide their full ratings on a continuous operation basis. A riser tensioner system consists of tensioners, power and standby APVs, air compressors, and a control panel. The tensioners maintain tension in the wire lines by taking up or paying out line in response to rig motions. The line being controlled is reeved over multiple sheaves at the blind and rod ends of the tensioner, over an idler sheave, and connected to the top of the riser pipe. Line tension is directly proportional to the air pressure magnitude. As the upward heave of the rig tends to cause an increase in line tension, the cylinder rod retracts, thus increasing the length of line. This maintains the selected line tension. When the cylinder rod retracts, air in the cylinder is compressed into the APVs. As downward heave of the rig tends to cause a decrease in line tension, the pressure force in the cylinder causes the cylinder rod to extend, thus maintaining the selected line tension. When the cylinder rod extends, air expands from the APVs to maintain pressure in the cylinder. Riser tensioners are fitted with an accumulator to provide an air-oil interface between the APVs and the cylinder. Oil in the accumulator and cylinder pressurized by air causes the cylinder extension force. This technique lubricates the high-pressure side of the piston and prevents cylinder barrel corrosion from the constant high-pressure air. The rod end of the cylinder is filled with oil. As the cylinder rod extends, the oil flows through the safety speed control valve and into the partially filled air-oil low-pressure reservoir. Retraction of the cylinder rod permits the low-pressure air in the air-oil reservoir to force the oil back into the rod end of the cylinder. During normal tensioner operation, the oil fully lubricates the piston packing and bearing and the rod packing and bearing. In the event of a wireline failure during operation, the cylinder rod will extend to its full stroke, but only at a controlled velocity. This prevents damage to the tensioner or adjacent equipment. As the cylinder extension velocity exceeds normal operating speeds, the back pressure from oil flowing through the speed limiting valve limits the extension velocity. Let's go over this again. The riser tensioner is designed to maintain a preset tension in a wire rope cable strung from a drilling vessel to a marine drilling riser pipe, which in turn is anchored to the ocean floor. To accomplish this, it must pay out cable and take up cable as the vessel heaves in the sea waves. The tensioner is basically a pneumatic spring and shock absorber using compressed air as the spring and a hydraulic cylinder as the damper. By using 4-part reeving, which is 2 rounds of the cable around the cylinder, a 4-to-1 ratio of line travel to cylinder travel is obtained, which allows the cylinder to rapidly compensate for any slack in the cable and thereby maintain a steady tension in the line as the vessel heaves. Tension is maintained in the cable by pressure in the tensioner cylinder. The amount of tension can be adjusted by varying the pressure level of the high-pressure air. Consider a drilling vessel in calm waters with its lines connected to the riser and the cylinder rods in mid-stroke with some pre-selected tension maintained by the air pressure in the APV and the cylinder. The trough of a wave passes and the rig heaves down. The distance between the riser and the rig is decreased, which tends to put slack in the tensioner cable. However, since the high-pressure air in the tensioner can expand, it does so, extending the tensioner cylinder rods and taking up the slack in the cable and maintaining the tension in the cable, which is slightly less than the original. If the crest of a wave passes the rig, causing it to heave upward, the distance between the marine riser and the rig will be increased, pulling a greater tension on the cable. This causes the cylinder rod to retract, thus paying out line and displacing air from the cylinder into the APV. The air is compressed slightly and causes a small increase in cable tension. In the tensioner system, combinations of standard pressure vessel volumes are used which result in approximately plus and minus 3% tension variation with heaves of 12 feet and the cylinder operating at about its mid-stroke position. Standby APVs eliminate the need for frequent use of an air compressor. During normal operation, no air is vented from the system. A high-pressure, low-volume air compressor air dryer system provides the high-pressure air for initial charging of the tensioner system. It also provides for charging the standby system. The air dryer reduces the water content in the air, which in turn keeps corrosion to a minimum. Complete control of the tensioner system is accomplished at a centralized control panel. This panel enables a single operator to start up, set operation, monitor, and shut down the complete system. Only infrequent attention by the operator is required. Most rigs have two riser pipe tensioners connected to wire lines from opposite sides of the riser, operating as a pair and with the same tension on each line. A system with at least two pairs of tensioners results in simplified and safer operation and permits higher tension levels in the marine riser. Greater flexibility is obtained with two or more pairs because tension may be maintained by one pair while allowing the second pair to be relaxed for maintenance or adjustments. Let's take a look at an extended life or XL riser tensioner system from the pressure vessel to the wire lines which are attached to the riser. At the power APV, we have a relief valve set for maximum pressures. This would be approximately 2,400 psi. The standard size for the 60,000-pound tensioner is one 275-gallon pressure vessel per tensioner. The 80,000-pound tensioners use three 275-gallon APVs per pair, or 1.5 APV per tensioner. Caution should be exercised with these high-pressure vessels. Personnel should always be careful not to bang heavy equipment into the vessel's sides. This could weaken the walls and perhaps make the APV susceptible to exploding. An exploding APV is similar to a bomb. Another control installed on the APV is a drain valve. Depending upon the configuration, the valve is usually found at the lowest part of the vessel. The valve is for draining off condensate water or for bleeding pressure off the vessel. Next is a shutoff valve. You should never use a cheater pipe on the handle of the valves. You can tap these valve handles, but cheater pipes can cause them to break off. The high-pressure air flows from the APV to the control panel. This panel connects or disconnects the power APV airflow to the tensioner. A standard system operates these units in pairs. In an 80,000-pound system, three air pressure vessels are connected in parallel, then through the panel to two tensioners connected in parallel. Remember, we said tensioners are usually operated in pairs. This method ensures that the diagonally opposing support lines on the riser pipe operate at equal tension levels under all conditions. In other words, you won't get any side loads or twisting as long as you have two pairs operating. Some rigs have as many as 8 tensioners or 4 pairs. The panel also permits control of the air compressor air dryer unit and operation of the standby APVs. High pressure air is directed from the air compressor air dryer to the power APVs or to the standby APVs. Also, high-pressure air stored in the standby APVs may be discharged into the power APVs. The main controls on the control panel are the start, stop, air compressor air dryer unit switch, and a pressure switch which shuts off the air compressor when its setting is reached. It does not restart the air compressor automatically. The air regulator, air oil reservoir control, which regulates the air pressure into the air oil reservoir, is normally set at 40 to 50 psig with the cylinder rod fully retracted. The air input is from the rig air supply. On the panel are vent valves which vent the air to the atmosphere. During normal operation, they remain closed. Air control valves which control the interflow of high-pressure air are operated as required. During normal operation, all valves between the tensioner and its power APVs are in the open position. Next are the pressure and tension gauges on the control panel. There are three types. One is a low-pressure gauge which indicates the pressure level in the air oil reservoir system. The second is a high-pressure gauge which indicates the pressure level in the standby APVs or the pressure level of the high-pressure air source. The third type is one or more high-pressure gauges, depending upon the system, which indicate the tension level. These gauges read directly in tension and indicate the tension per tensioner. The total tension obtained is the sum of all tensioners in operation. Next is a stroke position indicator. The stroke position indicator uses lights which indicate the incremental position of the cylinder rod. The switches are attached to one tensioner in each pair. There are 5 zones of indication. Fully extended, a red light will come on. At 2/3 of the extended stroke, a red and a green light will come on. At mid-stroke, just the green light. At 1/3 extension, a red light and a green light. And fully retracted is indicated by a red light. Next in the list of equipment in the riser tensioner system is the accumulator. The accumulator feeds pressurized oil to the cylinder as required. It holds a normal volume of 70 gallons with the relief valve set at 2400 psi. Oil in the accumulator is checked in the fully retracted position. On rod end up installations, the oil level may be checked by removing the relief valve on the rod end accumulator piping assembly and inserting a steel tape through the opening. The reading from the top of the nipple to the surface of the oil should be a minimum of 35 inches. Always replace the relief valve or plugs to ensure a leak-tight seal. Teflon tape should be used on the threads to ensure that they do not become galled or seized. Rucker always recommends using Pydrol 29 ELT, manufactured by Monsanto, as the standard hydraulic fluid for the tensioner system. It is used on both the blind end and the rod end of the tensioner. Your service manual relates basic hydraulic fluid information, such as which fluids may be compatible with the Pydrol if you have to use another type. You can mix some types, but don't ever use a mineral-based fluid in the tensioner system. The Pydrol is heavier than water, so if water is ever present, it will float on top. By taking a sample out of the system, you will soon see if there is water present. We also recommend using Pydratec 100 as a preservative. It is compatible with Pydrol. It is used on the exposed portion of the rod. Before handling Pydrol or any type of hydraulic fluids, check the service manual for toxicity information concerning personal and environmental safety. Another component of the tensioner system that we've mentioned already is the air oil reservoir. This reservoir, partially filled with oil, has a 40 to 50 psi air charge from the rig air supply. It is piped to the rod end cavity of the cylinder. Incorporated in the reservoir fittings is a rupture disc designed to rupture at 150 psi. Within the tensioner cylinder, there are several components that look like this. In your service manual, there are drawings which will give you the details you require if you ever have to change out any of the components. These components include such items as rings, packing glands, piston retainers, wiper rings, O-rings, bearings, cushion collars, spacers, the piston, and the cylinder. You probably have seen pistons put into the cylinders in automobiles. Well, that's similar to this type of operation. We have a rod and a piston with various rings and packing materials. They are placed into the cylinder like this operation at one of Rucker's sub-assembly plants. Before we get into pre-operational checkout and the operation of the system, let's take a self-check quiz. Turn now to page 2 in your workbook. When you hear the tone, stop the playback unit and begin answering the questions. Let's see how well you did on the quiz. The answer to number 1 is C, 80,000 and 60,000. Number 2 is true. Number 3 is A, BOP stack guidelines. Number 4 is D, pressure in the cylinder. Five is A. As the rig heaves downward, the tensioner's cylinder rods extend, taking up the potential slack in the wire line. Number 6 is true. Seven is C, hydraulic fluid. 8 is B, 4-to-1 ratio. Number 9 is F, mineral base hydraulic fluid, something we never use. And number 10 is true. If you didn't do too well, you might want to rewind the cassette and review the information again before going on. But if you are ready, let's continue. Before operating a tensioner system that is new or has not been operated recently, you should always perform a pre-operational checkout. Inspect all piping to ensure proper hookup. Check the oil level in the air oil reservoirs, and if the oil is low, correct it. Open air shutoff to the air oil reservoir and pressurize the air oil reservoir to 40 to 50 psig. The tensioner cylinder rod should be fully retracted. Open the air shutoff valve on the tensioners. If the tensioner is mounted rod end down, the wire line must be under tension to prevent the tensioner from extending. Then, check the oil level in the accumulator with the tensioner in the fully retracted position. On rod end up installations, the oil level may be checked by removing the relief valve. Check all sheaves to ensure they are well lubricated and free turning. Open the high pressure air vent valve on the tensioner. Open the high pressure air shutoff valve on the tensioner. Open all valves on the control panel. Start the air compressor air dryer unit and then check its operation while the high pressure vent valves remain open. Operate the valves on the control panel to allow pressure to build up in all power and standby APVs. Stop the air compressor at 150 to 200 psi. Vent air through each of the vent lines at the control panel and tensioner until clean and dry air is being vented. Direct air to the tensioner so that it vents through the tensioner's local high-pressure vent valve. Close the air inputs to the tensioner at the control panel end. Close the tensioner's local high-pressure vent valve. Operate the valves on the control panel to block air from the tensioners while directing air compressor flow to the APVs. Charge the power APVs to the desired pressure level. Charge the standby APVs to the desired pressure level. This pressure is normally twice that of power APVs or 2400 psi, whichever is smaller. Now the tensioner system is ready for operation, and valve operation should be performed with caution. Slowly open valves between power air pressure vessel and tensioners to make the tensioner system operational. The following instructions describe the operation of a standard riser tensioner system as controlled by a standard two-pair control panel. Ensure that the air oil reservoir relief valve setting is 95 psig. Close the charge APV valves. Close the activate tensioner valves. Close the compressor shutoff valve. Close the vent tensioner valves. Close the vent APV valves. Close the standby APV shutoff valve. To set the air pressure in the power APV for a pressure decrease, open the vent APV shutoff valves and hold until the pressure has been reduced to the desired level. To increase the pressure by using the air compressor, open the charge APV valves and open the air compressor shutoff valve. Start the air compressor and run it until the desired pressure is obtained. Now, stop the air compressor, close the charge APV valves, and close the air compressor shutoff valve. To set the air pressure in the power APV by increasing pressure with the standby APV, check the air pressure in the standby APV to ensure its level exceeds pressure already in the power APV. Open the charge APV valves. Crack open